In previous videos in this series, I've demonstrated how to display Three.js worlds in Hype in one of two modes. Either static or continuous rendering. In our early examples, static rendering employed a method called renderer.render to display an unchanging Three.js world that had been inserted into an empty element somewhere on the Hype canvas. Subsequently, continuous rendering was accomplished with an animation loop that refreshed our 3D world up to 60 times per second. This approach was also initiated on scene load by a method often called world.start. But once this method was triggered, it continued to re-render the scene every 16 milliseconds to give the impression of smooth motion for objects that change their position or appearance. As you can imagine, running an animation loop at this speed could easily drain system resources, especially on mobile devices with a finite battery life. Here, I'll expand upon these earlier lessons to create an intermediate solution called rendering on demand. Such rendering on demand strategies usually display a 3D world on scene load but then only re-render this scene in response to user interaction or outside events such as window resizing. This is a much more conservative approach that won't bog down your system or drain the battery on mobile devices. In general, rendering on demand is probably the most helpful approach to building apps with significant user interaction. In this video, I'll describe a Three.js example made for Hype that implements this render-on-demand strategy. In this example, I'll demonstrate how to display a simple 3D world that re-renders in response to two kinds of events. As part of this example, I'll also show how to construct a button natively in Hype that turns on and off the Three.js orbit controls. So, if this sounds interesting to you, let's start by taking a look at this demo project. So here's that project being displayed in a browser. I've included a link to the corresponding Hype project file in the description below so you can dig into the code further if you choose. But, as you can see, this example is very simple. It's just a static Three.js cube I've inserted into an empty Hype container. That element covers the entire canvas and includes a native Hype button that enables the Three.js orbit controls. The structure of this project is very similar to others I've created for previous videos in this series, and so I won't revisit the logic behind using JavaScript ES6 modules here. Instead, I've included links to the videos that explain that concept in the description below. While this project has no animation loop, we can still resize the browser window and have this cube scale and recenter appropriately. And after we turn on the orbit controls, we can also zoom, rotate, and pan the cube, like this. So you might be wondering how we can do this without an animation loop. Well, addressing that question is the primary goal of this video. Let's get started by examining how to dynamically redraw our Three.js world following a window resizing event. In our initial static Three.js renderings, we created code that enabled us to set the scene dimensions to match the size of the container holding our 3D world. This involves setting things like the aspect ratio of the camera and its field of view. This code was eventually collected into a separate module called resizer.js. The code in this module is split into two parts: an object that holds the initial dimensions of our 3D world and a resizer class that responds to changes in the window holding our 3D world. Looking more closely at the size object, you can see how we set the size and aspect ratio of our 3D world to match the browser window where it is being rendered. This includes updating the camera's viewing frustum, setting the renderer to be the same size as our container element, and setting the pixel ratio to match that of modern mobile devices where necessary. While in the resizer class, you can see how it includes an event listener that listens for resize events arising from the browser window. Following such an event, this class further readjusts the camera's viewing frustum and changes the renderer to match the new window size. While we didn't discuss it much at that time, this was the first step in creating a rendering on-demand design. Previously, when we switched to rendering inside an animation loop, we didn't need to invoke this class, but now it is an essential part of our rendering on-demand strategy. Back in our world.js file, you can see how we put this resizer class into effect. Firstly, we import the entire module at the top of world.js. Then we create an instance of this class as part of the world constructor function, like this. Next, we specify what to do when a resize event is received, namely, we run this.render. Here the word this refers to the world we've just created, and render refers to the main render function. If you scroll to the bottom of world.js, you can see that. It looks like this. And no surprise, that render function does nothing more than fire off the renderer.render method we have been using all along to create a single new frame. So, in summary, a single new frame is rendered for each resize event that is detected. When you resize a browser window, many intermediate resize events are detected, and each one is matched with a newly rendered frame, giving the appearance of smoothly animated movement. More generally, this is the trick underpinning our overall render-on-demand strategy. And that is, create an event listener for an event you are interested in, and then redraw your 3D world each time it fires. Events like these can arise in many different ways. Next, we'll examine how to use a hype button to fire off such an event. Now that you understand how our render-on-demand strategy works, the next step is connecting events generated from within hype with the re-rendering of our 3D world. The first step in this process is to make a representative hype control for this purpose. With this in mind, I've created a simple button using basic hype shapes and placed it in the top right-hand corner of our scene. There are 4 further steps to configuring this button for use with our Three.js world. The first step is to construct a timeline to control the animation of its appearance. Next, you want to link this button with a global variable that tracks changes in its state. I created such a tracking variable using hype custom data, and named it control state. This variable was created and initialized in a function named scene setup. The end result of these coding steps looks like this. This function runs only once during scene load. I've also written a custom hype function to toggle this tracking variable every time the button is clicked. That function is called toggle controls and looks like this. Finally, I've added a unique identifier to this control, using the hype identity panel, so that we can reference it from within our Three.js code. This is something we'll get to shortly. But first, our next step is to import and ready the Three.js orbit controls. This step is done in 2 parts. Firstly, we create a separate module called controls.js to import and configure our version of the orbit controls. For this to work, the file orbit-controls.js must be added to hype's resource pane. And inside the orbit-controls.js file, we need to make one small change. Specifically, the initial import statement must be adjusted to point to the correct location for the three.modules.js file. That location is also hype's resource pane, so we can use a relative path to signify that. The adjusted code looks like this. These orbit controls come with many settings, some of which I've included here as comments for your reference, even though they aren't necessary for our demo project. In fact, we're only interested in one setting here, which is the enabled property. We want to be able to set a starting value for this property and then enable or disable it from within hype. Initially, we do that by creating an initial state parameter in our createControls function. Later in the function, we use this parameter to set the controls.enabled property of our controls object. By default, this property is set to false and must be explicitly turned on for the controls to be activated. Next, we bring this module into the top-level world.js module and then use it to add these controls to our scene. Then, just as we did earlier, we need to set up another event listener that monitors our instance of the orbit controls for new events. You can see how I did that in this code block taken from world.js. In this case, the event of interest generated by the orbit controls is simply called change, and upon registering this event, we redraw the scene using the renderer.render method. As before, these controls emit many intermediate change events for each user adjustment. And just like before, these many incremental adjustments and subsequent re-renderings give the appearance of smoothly animated movement. The last piece of this puzzle is to construct a way to use hype button events to manipulate the state of our orbit controls. We do that in 2 steps. Firstly, we create a JavaScript reference to the hype button that we can use from within world.js. This is accomplished using the unique identifier we specified earlier in the hype identity panel. Once we have that reference, we can create one final event listener. In this case, our event listener will be listening for a click event. And when that occurs, we run a simple function that toggles the state of the orbit controls. You can see the JavaScript code for that here. And that's all there is to it. I hope you enjoyed this brief introduction to rendering Three.js scenes on demand within Hype apps. I hope I was able to convince you of the usefulness of this approach and how it represents the convenient middle ground between static and continuous rendering. This rendering on-demand strategy also lends itself to interactive 3D projects, and that's the subject of the next video in this series. So if you're interested to learn more about using the Three.js library in your Hype projects, keep an eye out for future videos on the Altered Mind Where YouTube channel.